It's like, it has to be cold.
No, it's good. Just gotta be not water. Us humans have been making drinks for thousands of years based upon the fact that water's terrible. Complicated. All right, page 198. Phil.
Bonding, Unit 5. Objectives. After studying this unit, the reader will be able to summarize general requirements for bonding, explain bonding requirements for services, summarize bonding requirements for other enclosures, explain bonding requirements for equipment if the voltage at the equipment is over 250 volts, summarize requirements for bonding loosely jointed metal raceways, explain bonding in hazardous locations, explain material for attachment of and sizing equipment bonding jumpers, explain bonding of metal piping systems and exposed structural steel, summarize bonding of lighting protection systems.
Does this sound like stuff we've already talked about 12 times already? Yes. Well, we'll talk about it again. All right, 250.90, Sir Alex.
250.90, general, the requirement. Bonding is required to be provided where necessary to ensure electrical continuity and the capacity to conduct safely and any fault current likely to be imposed. The concepts of the definition of bonded are shown in figure 5.1.
Alex, why is the ground wire allowed to be smaller than the neutral or hot conductor of the service? Why is the ground wire generally the smallest?
Because it doesn't need to conduct electricity all the time
Just,
for a short amount of time.
okay, just when there's a ground fault issue,
Yeah.
right? Cool. You know what, let's just read the discussion portion of just this one, and then we'll just kind of talk about everything as we go further. Do you want to take like a first paragraph, perhaps?
Discussion. The concept of bonding and its critically important place in this safety system were discussed extensively in the introduction to this book. The term bonded is defined in National Electric Code Article 100 as connected to establish electrical continuity and conductivity. Note that the only concept of bonding is included in the definition of the term. No size of conductor or installation requirements is included. These rules are provided in many sections of the NEC. In its simplest form, bonding completes a path for fault current to flow. Likewise, bonding extends the equipment ground and conductor path.
Cool. You want to take the next paragraph, sir?
Bonding is performed in many ways. The simplest perhaps is the connection of a metal conduit nipple to a metal box or similar enclosure with two lock nuts, one outside and the other inside. When installed and tightened properly, the nipple is connected or bonded to the enclosure. Then, when the metal nipple is connected to another metal box or similar enclosure, the nipple is bonded or connected to the box. In addition to the metal boxes are bonded or connected by the metal nipple or conduit.
All right, so if you look at figure 5.1, they're talking about something that we haven't been dealing a whole hell of a lot with yet. Metal nipple bonds boxes, right? We're looking at figure 5.1 at the top of the page. What's different about that nipple compared to what we've been using? We've been using a lot of EMT, right? This nipple is what?
Plastic.
What?
Plastic.
Nope.
Threaded?
Threaded because it's
Rigid?
rigid metal conduit, Schedule 80 most likely. So when you're using that, I know like when we're using the EMT connections, right? You put the pipe into the fitting, whether it's a compression or set screw, it still attaches to the pipe. The male threaded fitting goes into the hole and then the lock nut attaches it. Now that fitting can't go anywhere, correct? Now, if you look at this figure, there's a lock nut on the inside and on the outside of the box. That's because this is a threaded nipple. So, I mean, yes, these boxes can be firmly placed. Yes, we can put lock nuts on the inside, but if we don't put those lock nuts perfectly where we want them, there might be a little bit of slack. It might try pulling the boxes apart. It's better if we just go with two lock nuts and kind of lock them into each other. You know what I mean? And force it to just wedge between basically the two lock nuts in the box, causing that to be a nice firm connection. That's how it's done with rigid conduit. We haven't dealt a lot with that yet. But when you think rigid conduit and you think about putting that directly into the box, automatically think 2 lock nuts right off the top of your head. 2 lock nuts and a thread bushing to protect the threads. But, Colin, if we were dealing with something over 250 volts to ground, we wouldn't be using that plastic thread bushing anymore. What would we be using?
It'd be one that's made to bond it, right?
Yeah, just describe what it would look like.
It would kind of look like a normal thread bushing, except it had like a green screw or something to bond it to the
Beautiful,
conduit itself.
beautiful. And we like to put that there because it's just above the 208. It's just above 240, so residences in 280 3-phase get counted out. The only time you really have to play around with that is 480 or a single leg at 277. So I like that rule, it's placed perfectly. Good, good, good. Hit me with 250.92A, page 200.
Bonding of services. The requirements. The normally non-current carrying metal parts of equipment indicated in 250.92A1 and A2 are required to be bonded together. This includes the following: the service raceways, cable trays, cable bus framework, auxiliary gutters or service cable armor, or sheath that enclose, contain, or support service conductors, except as permitted in 250.80. All enclosures containing service conductors, including meter fittings, boxings, or the like, interposed in the service raceway or armor.
Does that make sense, everybody, if you look at that figure below? I mean, if they're metal components, it's gotta be bonded. This is not brain surgery at this point. Sarah, would you like to hit me with 250.92B?
Method of bonding at the service. Bonding jumpers meeting the requirements of this article are required to be used around impaired connections such as reducing washers or oversized
Concentric. Yep.
or eccentric knockouts. Standard lock nuts or bushings are not permitted to be the only means for the bonding required by this section, but are permitted to be installed to make sure mechanical connection of the raceways. Electrical continuity at the service equipment, service raceways, and service conductor functions. Closures must be ensured by one of the following methods.
Okay, just hit me with B1.
The requirement. Bond the equipment to the ground service conductor in the manner provided in 250.8.
Okay. Let's skip ahead. Colin, why don't you take 250.92B2? That's going to be on page 203.
More requirements. Connections utilizing threaded couplings or threaded hubs on enclosures are permitted if made up wrench tight.
Yeah, so hand tight's not going to do it. Wrench tight ensures a good connection. Okay, and that's with anything. You know, hand tight is rarely an effective means, even coming down to the MC connectors and the Romex connectors. You know what I mean? Hand tight, it's close, but that lineman is a permanent connection. Okay, but it is also a problem when righty tighty becomes righty loosey. So, so know the limits of what you're doing. I'm a notorious bolt popper. You know what I mean? It might take you a couple times to figure out how tight is too tight. I have broken many of single pole BR breakers in my life, just wanting to be a little too tight. Know though that there is probably a particular torque spec to every piece of equipment you're putting through. That isn't becoming a huge deal, but it's slowly gaining traction. Inspectors are now starting to slowly check torque specs. I mean, is it going to happen in your house? Doubtful. But in commercial facilities, possible. So just make sure everything is as tight as it needs to be. All right. And do we all know what a torque spec is? Have you ever heard that phrase before? Torque spec? You know, I mean, has anybody ever heard of a torque wrench? Okay, so like a torque wrench is just literally a wrench that has a dial or a clasp or a gauge on it that allows you to put it to, you know, like say you want to tighten something to 30 foot-pounds. You put that on, tighten it, and as soon as you go past that 30 threshold, you'll either hear a beep if it's electronic, or you hear a click to let you know that you've reached that 30 foot-pound mark. So that's what they mean by torque spec. Everything is in foot-pounds or in foot-inches. Please make sure that you're reading that carefully, because people explode fittings when it actually says 30 foot-inches of force and you put 30 foot-pounds of force on it. You know what I mean? Sir, 250.92B3, that's gonna be on page 204.
Threadless couplings and connectors were made up tight for metal raceways and metal clad cables.
Once again, just being tight. Why don't you read the discussion as well for this one?
Threadless couplings and connectors are suitable for bonding metal conduit and electrical metallic tubing if made uptight. Figure 510 shows threadless couplings on EMT. Threadless couplings are also available for use on rigid metal and intermediate metal conduit. Even though the code uses the word wrench tight in 250.92B2 and uses tight in 250.92B3, the requirement for making a secure connection should be treated equally. One loose conduit or tubing fitting will result in a break of the ground fault return path. A loose fitting can also result in arcing and sparking at connections, or may create shock hazard where energized equipment is at an elevated potential and other earth potential.
It can also allow a lot of contaminants in there: water, oil, bugs, pests. You know what I mean? It can allow a bunch of problems. And what they're referring to there, if you look in 510, those are compression couplings they're referring to. Compression couplings on EMT, when they're mounted outside, technically do make it a watertight connection, but once again, I never use EMT outside if I can ever help it. You know what I mean? I never consider that to be watertight. But a compression coupling, do we all know what a compression coupling is? Have you ever seen it, heard about it, talked about it? Okay. Actually, let me just grab one for you really quick so I can show you. These are compression couplings. The reason why we don't use them is I'm not a big fan. But you still have to know how they function. You can share. So this is a compression coupling. If you take apart one nut, you'll find smaller compression thread located within. You also see this little piece of metal. This little piece of metal is the magic to the whole mystery. This is called a ferrule. Just like a feral cat, that's exactly how you pronounce it, ferrule. If you break it down, this nut is gonna go over your pipe first, and please make sure you put it there, because a lot of people forget about this bad boy. So make sure you put it on there facing the right way. Then the ferrule is gonna slide on after that. So I'll use my pinky as an example. The nut's gonna go on, then the ferrule is gonna go on, and then the pipe is gonna seat fully into this fitting. You're gonna make sure it seats fully into that fitting. Then you're gonna pull the ferrule back and pull the nut back over that ferrule. When you tighten this nut down, that ferrule crushes onto the pipe, creating the seal, creating the connection. These things generally cannot be reused. Once they're put on there, the ferrule is crushed. You usually have to cut the pipe because it'll usually leave a pretty good sized indent in the pipe, especially if you torque it down as much as it needs be. Set screw connectors, you can just keep on reusing until the thread is messed up. So these are finicky. These have the habit of pulling out. They have the habit of loosening up. They have the habit of letting water in. They're kind of a pain in the ass to use. It requires wrenches versus just a screwdriver. There's many downsides, in my opinion, to these. But just know what they are, how they function, and that they do exist. They are rated, like I said, to create watertight fittings, but I don't buy that, not for a second. Please don't use EMT anywhere. There has to be a watertight situation. At the end of the class, just toss it back in here. Before?
Other listed devices such as bonding type lock nuts, bushings, or bushings with bonding jumpers.
And me and Colin just discussed that. So there should be no questions there. Yeah, if you look at figure 511, that just shows a couple examples. Before you put this on though, you want to make sure that paint has been scraped away from that panel box, creating a good connection. Like I said, those QOs, some higher class Eatons, the new Levitons, they're all painted. So they're not going to give you a good connection. You gotta scrape that shit away. Ooh, this is a good one right here. Page 206, 259.4A. Phil, talk to me about the grounding bridge.
So the intersystem bonding termination device, an intersystem bonding termination, IBT, for connecting intersystem bonding conductors must be provided external to enclosures at the service equipment or metering equipment enclosure, and at the disconnecting means for any additional buildings or structures. If an IBT is used, it is required to comply with the following. 1. Be accessible for connection and inspection. 2. Consist of a set of terminals with the capacity for connection of not less than 3 intersystem bonding conductors. 3. Not interfering with opening the enclosure for a service, building, or structure disconnecting means or metering equipment. 4. At the service equipment, be securely mounted and electrically connected to an enclosure for the service equipment, to the meter enclosure, or to an exposed, non-flexible metallic service raceway, or be mounted at one of these enclosures and be connected to the enclosure or to the grounding electrode conductor with a minimum 6-gauge copper conductor. 5. At the disconnecting means for a building or structure, be securely mounted and electrically connected to the metallic enclosure for the building or structure disconnecting means, or be mounted at the disconnecting means and be connected to the metallic enclosure or to the grounding electrode conductor with a minimum 6-gauge copper conductor. 6. The terminals are required to be listed as grounding and bonding equipment.
Perfectly timed. All right, so the grounding bridge is always used in residential applications. This is its holy grail. This is my service that I just installed in record time, might I add. Meters here, our lines go in. This will be a 100 amp service. So this is going to be 2 gauge, 4 gauge aluminum coming in, going into the LB. The panel box is somewhere back in here. Okay. This is the outside of the house. This is where the siding is. This is usually a standard house. Like there's some siding, there's a little bit of concrete before you get to the ground level, like 2-3 feet of concrete, fascia, whatever. Your service comes in. Your ground comes out of your panel box, right? Because it's just 3 conductors coming down, 2 hots and a neutral. No ground is coming down off of here. The neutral is grounded back up to the pole. We know that. But the ground comes from the panel box. So now I take my ground wire, I come out, you know, here, I can bring it on the inside, I can poke out here. I generally don't like coming through concrete. You know what I mean? If I can come through wood from the sill, I'm gonna do that every single time. So I brought my line from that panel box. This is on the inside. On the inside, I brought it up and I drilled a hole through the outside of the house. And now that's where my ground wire is poking out. You got me? We're all on the same page? Okay, I'm gonna erase a little bit. So now we're talking about this wire once it's exiting the house. And inside the house, I already bonded the water and the gas, right? I ran a line out for the panel box. I used 6 gauge because it's a 100 amp service. And I ran a line out, went to the gas line, and off of that, I ran over to that water and I jumped the meter. Boom, it's all back in the panel box. the water and the gas are grounded, or not grounded, bonded, right? Now I need to ground that system out, so I'm bringing that line out, like I said, and I just poked through. This is the one going to the ground rods, okay? But before it can go to the ground rod, I need to put a grounding bridge here, which is, if you look in the book, that little white thing there, that's what a grounding bridge looks like. It's a piece of plastic with a metal grounding bridge in there, and it's just strikingly similar to the neutral terminals you see on a panel box. It looks exactly like that. It's a bunch of terminals that you can fit up to a 4-gauge wire into, all right? So my line is gonna pass through that because there's always a section, if I'm looking at this vertically from the top, there's a bunch of holes that wires can go in the screw heads up here. But there's always gonna be one side that has like a hook apparatus. And there'll be a set terminal over here. So when that wire comes out of the house, I can just skin a little bit of the wire right there and just hook it onto that grounding bridge and not have to break that connection. So this wire is still a continuous wire. I didn't break it, I just skinned some of the insulation off. This is gonna be a continuous wire coming down to our first ground rod, or actually if I wanna draw the symbol correctly. And it's gonna come over 10 feet to our next ground rod. All this thing does is provide a place for your utilities to ground to. UGI, Comcast, satellite, all those, like even your water meter. All those sensoring devices that communicate with these companies that are on the side of your house, they all have to be grounded. And versus them knocking on your door every time they change it out, they can just latch that ground right into your grounding bridge. They don't even have to do it when you're home. You don't even have to know about it. They can just stop by, takes 2 seconds, boom, the meter's been upgraded. They can latch onto your grounding bridge. Everything's cool and kosher. That's the whole reason why we do it. When you use that grounding bridge, that line coming out to your ground rod, you should always pass through the one side that has a hook, just so you never have to break that wire. You know what I mean? Could you technically break one wire and put one in here and come out through there? Yeah, but an inspector might ding you on it. Even though that passes code, an inspector might ding you on it. Like he tried pulling that shit with me, and I pulled out this book and said, listen here, motherfucker, like you can still do this. And he passed it. But to avoid that trouble, always go through the one you can hook it on and not have to break that wire. They like it to be a continuous line going from that panel box out, down to the first one and over to the second one, all in one wire. Okay, so please keep that in mind. Are there any questions on the grounding bridge? This is an essential component when you hook up your service. And we're gonna be talking about that because you guys will eventually ground your services. But I just wanted to talk about that here before we did it in there and why we do it. So is there any questions? Okay. I'll tell you what, I'm quite the artist tonight. I'm killing it. Picasso better watch out.
So,
You know what? I thought that was pretty damn funny. Tough crowd. Okay, 250.96. Who are we at? Is it Alex?
Yes.
It's gonna be on page 207.
The requirement for 250.96, bonding other enclosures. Metal raceways, cable trays, cable armor, cable sheath, enclosures, frames, fittings, and other metal non-current carrying parts that are to serve as equipment grounding conductors, with or without the use of supplementary equipment grounding conductors, are required to be bonded where necessary to ensure electrical continuity and the capacity to conduct safely and any fault current likely to be imposed on them. Any non-conductive paint, enamel, or similar coating must be removed at threads, contact points, and contact surfaces, or be connected by means of fitting design so as to make such removal unnecessary.
Yeah, and they talk about paint and enamel and all that. There's also dirt and grime as well. You know what I mean? All that stuff should be off. You shouldn't like hit it with some WD-40 because even that can create a poor connection. You know what I mean? So it's just gotta be bare ass metal. That causes the best connection. Let's talk reducing washers. Hit me with the reducing washers. That's pretty important.
Reducing washers are used when the knockout opening in an enclosure is larger than the conduit or cable fitting to be connected. Reducing washers are used in matching pairs, one inside the enclosure and one outside. They are available in many standard trade conduit opening sizes such as shown in table 5.1. Note that metric equivalencies are not shown for simplicity.
And take the next paragraph as well.
The NEC doesn't specifically cover the installation of reducing washers, rather, at least so far as grounding and bonding issues are concerned. Article 250 focuses on maintaining an effective ground fault return path. So after the installation of the reducing washers is made, the integrity and capability of the fault return path must not be reduced. See figure 514 for a proper installation method for reducing washers.
Okay, so when you're using reducing washers, that should instantly throw up a red flag. You know what I mean? That's not going to be as reliable of a connection as just putting into a hub.
No,
Can you say
just
something?
moving the chair.
I'm sorry?
I was just moving the chair.
Okay.
There you go.
Yeah, they just don't, it's not as good of a seal. I mean, you're pancaking basically two washers together with two lock nuts to create a bigger seal because the hole was either made too big, something actually got torn out, you removed a service and putting in a new one that isn't quite as large. You know, there's a lot of reasons for using these large washers, but they do not have a good ground quality, in my humble opinion. You know what I mean? So even if like your volts are less than 250 volts to ground, you might want to engage in using that grounding bushing just to provide you a better path because it's always suspect. It's just like in my eyes, like any piece of conduit. You know what I mean? Like, it might be nice and tight when you put it on there, but it can always be subject to getting ruined and quickly. And if anything's going to get ruined first, it's going to be this. This one will be your weakest link. If anything gets pulled on, trust me, this is going to move before a strap moves. Just the nature of it. Any questions on that? Reducing washers, why we use them? Okay. So you want to take isolated grounding circuits, 210?
Isolated grounding circuits. If installed for the reduction of electromagnetic interference on the grounding circuit, an equipment enclosure supplied by a branch circuit is permitted to be isolated from a raceway containing circuits supplying only that equipment by one or more listed non-metallic raceway fittings located at the point of attachment of the raceway to the equipment enclosure. The installation of the metal raceway must comply with provisions of this article and must be supplemented by an internal insulated equipment grounding conductor installed in accordance with 250-146D to ground the equipment enclosure.
Okay, and if we remember correctly from previous weeks, we're two instances that will see these type of deals. Two commonplace areas that will see these kind of circuits. Well, let's think, let's dig deep. Phil, what do you got? You got one for me?
Like communications equipment, right, isolated ground?
Yeah, okay, so I'll go with 3 then.
Sub-panels? Sub-panels?
We're talking like circuits, not like
Okay.
services. But no, that you are still right on that, though. Where do you go if you get hurt?
Hospital.
Ooh, hospitals, right? You have a lot of sensitive equipment in there. And also, lastly,
Airports.
I can see that, but I'm thinking more constant. You're not gonna be in an airport all the time, but every building will probably have this in it. Come on, it's 2021. Everything's Wi-Fi, everything's Bluetooth, everything's cellular. Server rooms, right? Kind of communication equipment, kind of not, you know what I mean? That's a gray area, so. Okay. Sir, bonding for over 250 volts.
For circuits of over 250 volts to ground, electrical continuity of metal raceways and cables with metal sheets that contain any conductor other than service conductors is required to be insured by one or more of the methods specified for services in 250.92B except for one.
You want to just take 1 through 4 there on the right?
Threadless couplings and connectors for cables with metal sheets to
Oh wait, these are the exceptions, I'm sorry if you didn't catch that, these are the 4 exceptions to this rule. All right, continue.
2 lock nuts on a rigid metal conduit or
Intermediate.
intermediate metal conduit, one inside and one on the outside of the boxes and cabinets. Fittings with shoulders that seat firmly against the box or cabinet, such as electrical, metallic tubing connectors, flexible metal conduit connectors, and cable connectors with 1 lock nut on the inside of the boxes or cabinets or listed fittings.
Colin, you want to take 250.98?
Bonding loosely jointed metal raceways. Expansion, deflection, or deflection fittings, and telescoping sections of metal raceways are required to be made electrically continuous by equipment bonding jumpers or other means.
And so if you look at figure 518, like we were talking about with PVC, you know, like PVC expands greatly when it's exposed to sunlight and heat. Rigid conduit, not so much, you know what I mean? But there are still instances that we want a flexible connection, you know what I mean? Or if we need to have it give a little give, if it's like a very long straight run and the building temperature frequently fluctuates, you know what I mean? You might want to have an expansion fitting there. You can either jump it with clamps and some wire, or you can use a rated fitting like you see here in 518. That takes care of the expansion and the grounding all in one fitting just because it's specifically designed to do so. All right. More often than not, though, you're just going to go with 2 clamps and a piece of wire. You know what I mean? And Nicole, how would you size up that piece of wire? You just grab anything in the back of the truck, throw it up there. Or how would you size that grounding wire? What would you be thinking to look?
You'd be looking at the wires that are bringing in
To the
current.
service.
Yes.
Beautiful. And it's not going to be as big as a neutral. It's going to be a lot smaller, just because it's not designed to carry power long term. It's only designed to carry power for 1 or 2 seconds during a ground fault situation. Cool. We're learning something. Let's talk about hazardous locations.
Bonding in hazardous classified locations. Regardless of the voltage of the electrical system, the electrical continuity of non-current carrying metal parts of equipment, raceways, and other enclosures in any hazardous classified locations as defined in 500.5 is required to be insured by any of the methods specified in 250.92B2 through 4 that are approved for the wiring method use. 1 or more of these bonding methods must be used whether or not supplementary equipment grounding conductors of the wire type are installed. Specific requirements for bonding and providing the effective ground fault current return path are contained in the following code locations.
You don't have to read that. Nicole, hit me with A. Let's talk about material for that.
Equipment bonding jumpers are required to be copper, aluminum, or copper-clad aluminum, or other corrosive resistant material. A bonding jumper is required to consist of a wire, bus, screw, or similar suitable conductor.
We all talked about that before, yeah, whether it's that hunk of metal has to be big enough to carry that ground fault current for those 1 or 2 seconds, you know what I mean? And it's gonna be in correlation to the size of wire that you would have used. You know what I mean? So if you're gonna be using a 3/0 wire or a 3/0 conductor for your ground, you're not just gonna use one of these little terminal screws, are you? You know what I mean? That's gonna be greatly outclassed. So you wanna use the appropriate size fitting for the appropriate size ground. Nicole, you wanna take B as well?
Yes, sir. Bonding jumpers are required to be attached in the manner specified by the applicable provisions of 250.8 for circuits and equipment and by 250.70 for grounding electrodes.
Cool. Phil, you wanna take C?
Sure. Size supply side bonding jumper. 250.102, size for supply conductors in a single raceway or cable. The supply side bonding jumper is not permitted to be smaller than the sizes shown in table 250. It is important to recall that for
No,
bonding.
you're good. And once again, that table is located just to the right, and it shows you clear as day what size ground conductors you're using for the size service you have coming in. It's a very simple equation. Very, very, very simple equation. I don't require you to memorize it, but just please make sure, we're electricians, guys, we know where to look. You know what I mean? And it's always the code book. And versus you doing a lot of calculations, I always like looking at a table. You know what I mean? Tables are great. Who's up there? Phil? Hit me with 250.102E. It's gonna be on 218. 218, everybody.
Installations. The requirements. The equipment bonding jumper is permitted to be installed inside or outside of a raceway or enclosure. Inside a raceway or enclosure, if installed inside of a raceway, the equipment bonding jumpers or conductors are required to comply with NEC. Outside a raceway or enclosure, if installed on the outside, the length of the equipment bonding jumper is generally not permitted to exceed 6 feet in length and must be routed with the raceway or enclosure.
Now, that's obviously a less desirable method. You know what I mean? You always wanted to have it in the raceway. If it's outside the raceway, it's subject to damage, it's subject to people messing with it, it's subject to corrosion, anything. You know what I mean? Loosening fittings, anything. And like Phil said, generally it's not allowed to go over 6 feet. I think in reality, 8 feet is really the longest you can have it if memory serves. But just know, inside the conduit is always a better method. There will be instances they have to go on the outside, but just please make sure, once you see that 6 foot mark, know that you have a problem. You know what I mean? 6 feet is usually the number for any external ground fixed to that conduit. When they mean fixed, it could be taped on. Generally, I see it taped on, zip ties, wire ties, you know, any methods like that. You're only going 6 feet. Okay? Okay.
Yeah, with that.
You want to take 250.104A? It's going to be on page 219.
Metal water piping. The metal water piping system is required to be bonded as provided in NEC. General 250.104 general, the requirements. Metal water piping systems installed in or attached to a building or structure shall be bonded to any of the following: service equipment enclosure, grounded conductor at the service, grounding electrode conductor if of sufficient size, one or more grounding electrodes used if the grounding electrode conductor or bonding jumper to the grounding electrode is of sufficient size.
Now, me personally, I really like going to the neutral on the main panel box, or to the ground bar in the main panel box. They're both bound there together, so they're essentially the same thing. But that's where I really like attaching the bonding line for my water and my gas. And if I can try, I'm going to hit both of those in the same wire. Usually I'm going to hit my gas first, if I can help it, and then I'll hit my water, because the water, you always have to jump that meter. and the gas meter is always outside, so I don't have to worry about jumping that bad boy. So I just hit a single gas line, go over my water line as close to the meter as I can get it, and I'll throw a clamp before and after the meter. Now you want to make sure, this is a plumber thing in me, but I'll just give you guys the heads up. You guys know what unions are, right? It's not a coupling, it's a coupling that can be taken apart, correct? On water lines, they have something called like a dielectric union, and that could cause a little bit of separation there. So be cautious of that. Be cautious of any time the water switches to PEX and then back to copper. You know what I mean? Because if you bond it as copper, then it switches to PEX and it goes back to copper. Well, the copper on the second side is isolated. You know what I mean? If you see a big chunk of PEX there, like for repair, you know what I mean? It always happens on the main. If you see a piece of PEX there, treat that PEX like it's your meter and jump that as well. You know what I mean? Do we all have any questions on that? Do we know what I'm talking about in regards to that? Okay. Yeah, always keep on the eye out for, keep the eyes out for a union or for PEX in that copper system.
How about like push and fittings, like connectors, like do they still like insulate? Like
A compression
shark,
fitting?
Yeah, like a shark bite or something, because that's still, I know there's like a gas.
A shark bite, I would consider it to be like a union, and I would jump that as well,
Okay.
because it's sealed via a rubber gasket. And two, and this is, once again, this is plumber coming out of me, it all depends on what type of shark bite you buy.
Yeah.
If you got like the Shark Bite brand, Shark Bite, they're solid brass construction. Other companies have plastic construction. Others, I know like Shark Bites, like when that copper goes in, it butts against a piece of brass, or not brass, oh yeah, it is brass. The teeth are stainless steel, so it's never gonna corrode, but it seals via that gasket. So there's not gonna be, no, I wouldn't consider that to be.
Okay, just out of curiosity, I don't know.
Yeah, especially if you have a plastic one, that's right out.
Yeah.
But yeah. And that's another instance of other countries using technology for like 30 years before you even touched it. Like that was actually created in Australia. And they're so commonplace down there that it's actually common to bury them in walls, where you wouldn't do that here. So, food for your thought. Food for your thought. Hit me with who's up here? Hit me with 250.104A3. That's gonna be on 220.
Buildings or structures supplied by a feeder or branch circuit. The metal water piping system installed in or attached to a building or structure shall be bonded to any of the following. 1. Building or structure disconnecting means enclosure where located at the building or structure. 2. Equipment grounding conductor run with the supply conductors. 3. One or more grounding electrodes used. The bonding jumper shall be sized in accordance with NEC. The bonding jumper shall not be required to be larger than the largest ungrounded feeder or branch circuit conductor supplying building or structure.
Does that make sense, everybody? Any questions regarding that? Yep. Ooh, this is a good one. Talk to us about some structural metal. Let's talk about some heavy metal. What do you guys think? Heavy metal, anyone? No chuckles? Tough crowd, Jesus.
Structural metal. Exposed structural metal that is interconnected from a metal building frame and is not.
To form a metal building frame, not from, to form. Sorry but that's a pretty big difference.
To form a metal building frame and is not intentionally grounded or bonded and is likely to become energized shall be bonded to any of the following. Service equipment enclosure, grounded conductor at the service, disconnecting means for buildings or structures supplied by a feeder or branch circuit, grounding electrode conductor if of sufficient size, one or more grounding electrodes used if the grounding electrode conductor or bonding jumper to the grounding electrode is of sufficient size. The bonding conductor or jumper shall be sized in accordance with table 250-102C1, except that it shall not be required to be larger than 3/0 copper or 250 casing mill aluminum or copper clad aluminum, and installed in accordance with NEC. The points of attachment of the bonding jumper shall be accessible unless installed in compliance with the NEC.
And keep in mind, when it's structural steel like that, and I'm not sure if you guys are gonna ever have to deal with this, but if you do, normally you only have to hit it at one point, because it's structural steel, it's the core of the building, it's the skeleton of the building. It's all connected by very firm methods. You know, it's bolted in place with thousands of pounds of force, or it's welded with inch-thick welds that will never ever break apart, ever, 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 ever. So just one spot is going to get that entire building. So just keep that in mind. And also, the structure can be used as a ground rod itself, because 9 times out of 10, those pillars are gonna go in the ground at least 10 feet minimum. I'd say probably a lot further. So any structural steel that's below grade, 10 feet or more, can be considered a grounding electrode. And we talked about that before. So just know that if it's steel structure, if it's been bonded in one spot and it's not used as a grounding electrode, you've bonded the entire building. And you bond it according to the size of,
Larger sun grounding conductor.
boom. Wow, we went through the chapter pretty damn quick. Let's briefly talk about lighting protection. 225.
Lighting protection systems.
Lightning.
Lightning.
Protect us from our lights.
The lighting protection system ground terminals, grounding electrodes, are required to be bonded to the building or structure grounding electrode system.
Cool, I'm happy with that.
Good.
All right, I think that's gonna be it for this week. I'm gonna push 2 chapters in commercial, I'm just gonna push the 1 chapter in grounding and bonding. Does anybody have any questions as to what we discussed today? I know we keep on hitting the horse raw, but we do creep upon some new information every once in a while. And I think me being very repetitive might help your retention. You know what I mean? So please, if you have any questions, I know this was just about bonding. This will be a pretty easy one. Next week won't be so easy if memory serves. So just please be cautious. All right? No questions? All right, let me stop the video so we can talk about answering.